Okay, thank you, Christine and John. Unfortunately, Peter and Melanie couldn't be with us this morning, but we are glad to have another executive, Billy Bardin, from Dow with us. And maybe, Billy, I was thinking maybe you could start, introduce yourself, and maybe add a little perspective from your side. Could you do that?
Sure. So I'm, as Andy said, I'm Billy Bardin. I'm the Global Operations Technology Director for Dow. So I have oversight for our manufacturing technology organization, which includes the Manufacturing 4.0 program that Peter and Melanie were discussing earlier. And I think they covered it quite well and gave a good perspective on the historical journey upon which we've been traveling for the last several years. And for those that have been at this conference before, we've been here. I've been here on the panel in previous years and talked about some of the issues that Melanie and Peter were covering around culture and understanding. But I think the take-home message from that presentation, first of all, you see them here together, which is critically important, right? In order to deploy a digital strategy or a manufacturing 4.0 or industry 4.0 strategy within the production organization and across R&D and process R&D, supply chain, and logistics, you have to have both. You have to have both your IT organization backing you with the infrastructure and the knowledge of how to deploy that accurately, and you have to have the operations and production organization be first willing to accept that technology, but also understand how it changes the work process. And so both of those elements are required. The fact that Peter and Melanie understand that, and the fact that they're here together and they work hand in hand day after day to make sure that happens. What they said is true. I mean, you see it. Melanie sits in our tech reviews. We sit in their tech reviews, and it's one team. And I think that really gets to the underlying approach at which we're trying to take at Dow in terms of pushing the envelope in the digitalization arena. I think the other component that you see is where I sit, it's fortunate to have the senior leaders in the organization pushing this. So you see Peter and Melanie are bought in. They're strong advocates. They can help bring our business presidents and our collaborators and other parts of the organization along. And they also have influence up with the rest of our C-suite leadership and our CEO who has this as a key platform in his tenure leading the company. And so having that senior leadership perspective, the ability to push and deploy resources also helps make things easier for us when we want to go try something.
Thank you. I think most of you folks know Don Bartusiak of ExxonMobil. Don, maybe you could introduce yourself and perhaps say a few words about open process automation. As you know, Don is the leader of Process Automation Forum, and maybe you could give us a little update on that.
Thanks, Andy. Don Bartusiak. I'm the Chief Engineer for Process Control in ExxonMobil Research and Engineering. If I may, Andy, I want to first touch on maybe just a brief comment on digital transformation. I think one characteristic, and you see it already in the theme of this morning's session, is that one characteristic of the transformation is our ability to leverage IT technologies in the process control and OT space, and the entrance and emergence of the big, powerful IT companies like Intel, for example, like Microsoft. And that also enables the coming into the marketplace of the small, innovative companies. And this is really the ecosystem that we aspire to get to. So on Open Process Automation Forum, we have several sessions at this year's ARC Forum about that. So I don't want to steal any of the team's thunder, but on Thursday morning, we will have an ARC Forum session, 8:30 to 10, where we're basically going to give this community a full status report on what we have done and what we are doing in the year or two ahead. I'll stop there, Andy, if I may.
Good, thanks. I want to comment, please have your questions ready. If you do have a question, raise your hand so that one of ARC person could bring the mic to you and so forth. We'll start. So we have a question, folks, here. In the meantime, maybe I could ask you folks challenges. Obviously there are a lot of challenges. And perhaps maybe John and Christine, you could talk a little bit about how are you helping your customers, perhaps with digital transformation, because most of your customers, are trying to go through this journey, and you have a process. How are you helping? Maybe I could start with you, Melanie. Go ahead.
Christine, yeah. So I'm gonna start with the obvious one first. It's actually a workforce challenge. The biggest challenge that I think we're going to face, and I loved the first talk with the Dow team. At Intel, we realized pretty early on that we needed to bring in our own factory operations, we needed to bring the IT with the operations of our factories, or there was no way we could be on the journey of the kinds of capabilities that are required to really realize the full potential of the information that's flowing. We have petabytes of data that are flowing off of our fabrication facilities that we have to act upon. You can't do that with traditional approaches to manufacturing and really having the IT infrastructure and the data there. But then you have to really deal with having the right workforce that can handle it. And where they've been separated for so many years, it's critical for that cross work to happen. But then the other aspect of it is, how do you really bring those IT capabilities into the industrial space? I mentioned one, the deterministic of networks, et cetera. They weren't built that way, and that's what you need if you're going to bring some of these more open IT capabilities in, and those types of technologies. So that's where we are focused. How do we have the right solutions that utilize the goodness there, but also have the industrial features that you require when you're bringing them into an automation and control type of space, such that you still have that flexibility of moving workloads around, orchestrating them, et cetera, but you can do them in a way that is ready for the industrial infrastructure space. And so that's where we're trying to help overcome those kind of challenges as you bring more of these open systems in, such that you can have a range of solutions there. So.
Yeah, I see it consistently when we go to market and try to help clients. And I think the common theme is, look, we're an old company. This factory is 50 years old. Some of our equipment's that old or a little bit newer. And how do we get data out of it, and how do we utilize it? So I like to talk about case studies, not just Microsoft and our tools and advertisement. The Sandvik Coromant company in Germany, they make tool bits. I mean, steel cutting tools. Essentially, they're about 150 years old. They had a problem with an aging workforce, and these were the experts. They call them yellow jackets. They actually walked around the factory in yellow coats, and they were the 40-year veterans who understood speeds, feeds, temperatures. They could feel a machine and understand what was wrong with it if it was a wrong tool cutting that metal. They decided to transform because they were seeing those guys exit, and the new kid, the kids on the block weren't really necessarily getting into manufacturing as a career. So they decided to create an AI-based model that took the knowledge of these experienced workers, combine it with data off of the machines, the tools themselves, et cetera, into a pretty impressive combination of solutions where it's managed by a central hub or nervous system, and it's monitored remotely. And now they sell it as a service out to their customers. So Cummins Engine in Indiana has bought Sandvik Coromant machinery and equipment and put it into their plants, and that piece of machinery is managed remotely. So when an issue does come up and they see it on an analytic inside of an algorithm that they've written inside of the screen, they actually then can send a signal off to somebody and have them go do the repair. But companies are transforming, in this case, going out and creating a model to help them create a new business entity.
Thanks. Okay, we have a question here. Go ahead, David.
Yeah, hi, Dave Lafferty, iXtend. I'm pretty involved in the innovation space in Houston, and so I'm very curious. It was a great talk from Dow on the DOC, and I'm seeing lots of companies struggling with that whole thing. So my question is, how do you find new companies with new ideas? Is there a formal pitch process or screening process that you do to sort of refill the hopper with new ideas?
We use we use multiple pathways to find and identify partners or potential partners with whom we want to work. Certainly, our digital operations center and our director for the digital operations center, Clark Dressen, is here. You probably have a chance to chat with him later on during the week. Is one forum in which we introduce potential collaborators. You know, in Houston, we have the GHP, Greater Houston Partnership, and Houston Exponential, with which we're heavily involved, looking at startup companies. We reach out to incubators across the different regions. So we have a hook into some Asia Pacific incubators. We're starting collaborations with a couple of locations in Europe as well as in Israel, for example. So we use, I mean, Dow's a global company. We have global reach, so we use that global presence and our local offices to help identify that potential collaborator or someone that comes with a new idea. We're actually doing some challenges in certain ecosystems where we push out a challenge. Here's a problem we want to solve. Bring us your proposals. So we use a number of different methodologies to try to identify that. Whatever seems to work best in the local area, we adapt.
Let me ask Dr. Löser, how do you go about in Germany?
Yeah, it sounds very similar to what we're doing. There's always, we do active scouting, of course. A lot of companies approach us with new ideas, telling us, hey, listen, we have this really cool feature. Would this be useful for you? What then, for me, the critical part is how do you get these solutions that work really well implemented into our factories? Because due to the special challenges of implementing it into your brownfield factory, those are usually the things that make it difficult implementing these things. And that's the tool of the Audi production lab we use there. So we have companies come in, show us in a lab environment first what they tell us what they can do, and then from there we can evaluate, okay, is this helpful for us or not? With the classical technologies, I mean, we're a metal bending company. If you tell us how you have a new stamp to stamp metal sheets with more power, more pressure, more speed, we know exactly what that means and whether we need it or not. But with the new technologies, that's something different. And so one of the key things is to actually try it out, get our hands on those new technologies, and experience ourselves that it's helpful. And by doing that, we have the chance to actually evangelize our graybacks in automation, which we need in order to push these technologies out into the factories.
So, Dave, in our case, we do it two ways. One, as a natural work process in the way we do research and development, either in my engineering company or the research company of ExxonMobil Research and Engineering. The first step in the process is understand the state of the art, which frequently turns out to identifying these small companies that have great ideas. And as part of that, we actually also have a lot of partnership relationships with universities, which is another source of new technology for us. So that's one way we do it. And my colleague, Dr. Kiran Sheth, is on point for a lot of that work. He's here today. The second thing I'll highlight is a couple of years ago, we started a technology sourcing and ventures organization within our research organization, which does the same thing, goes out and finds innovative solutions to our problems. And Tim Westhoven and Doug Kushnerek are here from that organization. So that's what we do.
Excellent.
Can
go
I just
ahead.
add one more thing? So the organizations that we have at Intel, we have three that we really focus in on. We have our Intel labs, and those labs work with the business groups like where I am, but also with our factories and really understanding what are the innovations and driving those. We also have a Intel Capital, an investment arm. They are out there for all of the businesses Intel is in, really looking at where we can invest for those future and identifying some of those new innovators and how we might work with them and or investing them along. And then, of course, I mean, research in the various areas, funding projects, especially in some of these, in the industrial space, some of these consortiums that are driving the next generation of paths for innovation.
Thanks, Chris. Okay, we have a question over there. Go ahead.
Yeah, this may be more institutional management, traditional, but how do you stream new technologies or really evaluate them? And this is for the users. Exxon, Dow, and Audi, to evaluate them and stream them into an organization relative to existing purchase practices, purchasing long-term purchase contracts, strategic technology, they call them technology purchase agreements with vendors. Don knows exactly what I'm talking about. He's shaking his head. But how do you protect against that? You know, I had been in a large company and we were trying to do some of that with some success, but there were certain institutional things that really were serious blocks to that. How do you attack that problem?
Yeah, Bill. So that I can't comment on our procurement strategies. Okay, that's deeply commercial, and I can't touch that third rail. But you're asking a great question. How do you innovate in a context? I mean, Henning expressed it very well this morning. You have this dilemma of manufacturing excellence, which doesn't want to change anything, versus the need to innovate. This sets up what we used to call a dynamic tension. And I guess the short answer that I'll give to your question is where we identify strategic opportunities that will compel us to challenge the way we've been doing something, which may include a procurement strategy, then we'll go after it. But you got to build a coalition of the willing and get a lot of management support to change a big machine. There's an enormous inertia behind that, and I think that's really the genesis of your question.
Yeah, I would say the same for us. From a chemical engineering perspective, the activation barrier to change a strategic supplier is quite high. You have long-term relationships. You have the ability to leverage across a company, as Peter and Melanie were talking about. One of the things that we've done very successfully is to bring our purchasing colleagues and our purchasing contacts into our technology evaluation process. So we have them at the table early on. They come to many of our digital operations center technology reviews when we're looking at new technology. And ultimately, they can be convinced if you show there's an appropriate value case of why you need to change. Is there more money to be made by making this change against a strategic contract or a discount you might get from a strategic supplier? That hurdle, that activation barrier has to be overcome. And so we try to bring them in early as possible into that discussion, even to the point of helping us negotiate what proof of concept pricing might look like, so that we set a good standard for what we might want to do long term if we're successful with that proof of concept.
Henning, would you like to add a European perspective?
Yeah, I can agree with what you two said. Maybe to add one more thing, the idea of you have somewhere in your company there is this idea popping up, and you say, hey, if we would do this, if we would look into this data, and if we find what we think we can find, that would be a real cool business value for us, for our operations and everything. And then you come into what I call a vicious cycle, because then you go to controlling and you tell them, hey, listen, I've got this really cool idea. I need to invest some money in order to figure out, will this work? And they say, okay, are you sure this will work? And he said, well, I need to look into the data first, then I can tell you if it will work. And then it goes to the next step. So controlling says, well, then I can't give you the money because there is no benefit in there. So what you need there is some small part of your organization to have the power and to have the mandate to think outside the box and to break rules. Because what you can do then is, with investing very little money, tapping into the data, figuring out, okay, is this helpful or not? And once you found out, yes, this is helpful, then you can calculate the business case, and you can set it up from a proof of concept to how do you scale this out into the factories. And that's what you want at the end. You want to scale it out so that you can leverage what's in there, but you need to overcome this activation barrier in order to really tap that.
Excellent. Okay, folks, please raise your hands if you have any questions. Let's see your hands. Oh, a couple of, I know you have it. I'm trying to get the next one, David. Okay, please raise your hands. Okay, go ahead, David.
Okay, good morning, panel. David Brosel from the Manufacturing Leadership Council. kind of a bit of a question around where are we all headed with this? Let's say we get really good at everything we've been talking about this morning. We break down the silos, we achieve real collaboration, we build the ecosystems, we get really, really good at mining the data. Flash forward to 2030. What's the future state of our factories and plants? What do they look like? Are they autonomous? Are they lights out? Are they self-learning? Are they going to be pretty much just what they are now, but just faster, more efficient? What do you think the future state looks like in 10 years? What are we heading toward?
Okay, real quick.
It seems like Henning is...
That's a great question. And for me, I think there is no general answer to that, because you need to look at your individual company and figure out what are your roots, what is really the value of what you're doing. For us in Audi, what I can say is we strongly believe that building a car is and will stay craftsmanship. It's a high volume production, but it's craftsmanship. And so at the very end, actually assembling the car will be a piece of craftsmanship which workers will do, but everything that is not actually adding to or helping for this added value for this craftsmanship, that will be automized. So logistics will be automized. There will be much more support systems telling workers what to do, where to help, and all these kinds of things. But at the end, if you want to have a premium product where you can see this craftsmanship, it has to be craftsmanship. You cannot automate that.
So David, in 2030, we will still be replacing 1980s vintage control systems. Okay. But the role of the console operator, we are going to see more autonomous types of operations. I mean, the types of solutions we deliver to the console operator in broad terms will be characterized as having more autonomous characteristics. My colleague Apostolos Georgiou is going to give a talk about this on Wednesday. But beyond the console operator, I think our maintenance staff are going to be vastly more digitally enabled than they are today. Peter and Melanie this morning hinted at it very, very briefly. We're investing very heavily into that. And then the other thing, and I'll stop, I think the way that we project process engineering talent at our manufacturing facilities is going to be done at an above-site level, so that our process talent, our equipment experts see the whole fleet rather than being physically located at one facility servicing that one site. I think they're the general characteristics of what 2030 is going to look like, Dave.
And I'd like to add on. So today I'm in the business group. How do we apply our products and technologies? 15 years ago, I was in the executive office of the group that runs our factories, our fab sort manufacturing, so our continuous processing. At that time, we were just starting to introduce the concept of a remote operations center. We were just starting to introduce the idea of automated material handling. We went into many of our factories at that point. We had people wheeling the wafers from machine to machine, operators interacting with the machine to start the process steps. Fast forward to where we are now, we can run a factory on an exception basis from remote operations centers. We have automated material handling. But I'll tell you what, our journey isn't done, right? We continue to look for how else can we look to how we maintain our equipment with better insights. I know Rob Colby from our manufacturing IT organization is going to be sharing some stuff we're doing in that space. So we continue that journey even with the high levels of autonomy we have. And we had to, with the kind of geometries that we're dealing with in the semiconductor and those process steps, we had to do this to be able to advance to where we are today. And I think That's what we're going to start seeing over the next 5 to 10 years, is industries able to utilize these kind of capabilities and get to similar states. And I see those companies happening now.
Yeah, I would have to agree with Don on the age of the facilities. We just deployed a whole fleet across the process industries, a whole fleet of plants that have come on stream in 2010, 2011, 2012, 2015. In 10 years, those are still going to be running. They look pretty much the same. In fact, we're still running plants that are 60 or 70 years old and older inside of Dow, right? So those assets aren't going to change. There's not a disposition to get to shut down economics with this. I think what you're going to see is fundamentally moving from a plant-based optimization approach or a manufacturing site optimization approach where we've been very successful in deploying things like advanced control and optimization and real-time optimization, moving from a plant to basically an enterprise-wide optimization or a value chain-wide optimization where you get real-time feedback that dictates not only your production plan, but your shipment, your raw material scheduling, and what shows up at your customer and how your customer's inventories are impacted. That full value chain optimization, applying what we have from AC&O and RT-Op and the forthcoming AI technologies into the value chain, I think is really the fundamental difference. What you see, you're going to see more connected worker, you'll see more digital enablement, but that value chain wide look is probably the key difference than what we had in 2020, for example.
Excellent. I believe we have a question over there.
Yes, good morning. This is Jacqueline Arnold with Hexagon. Real simple question. It's highly debated among a lot of software vendors currently. But what is your current state and your future strategy for a cloud adoption of your operational data and solutions?
Good question. Who would like to start? Go ahead.
Sure, I can take a stab at it. I think that's, for us at least, it's going to be very much technology dependent. So as I look at our previous 20 years, of course, we're very much on-prem type solution, or at least in Dow-controlled on-prem solutions. I think we will see both at the enterprise level, so some of you think about finance data, HR data, enterprise or corporate data, that flows more easily to a cloud solution. And to be frank, there's some process technologies and intellectual property which will never leave the Dow fence line. It will never be on cloud. It will either be on-prem on a process control server or somewhere that has physical and cyber security fence line that is highly, highly regulated. So it just depends. We have technologies that are going to be on cloud, and we have some that will never be on cloud. So to answer your question, a mixed platform is what's going to be required for us, I believe.
How about your perspective, Henning?
Yeah, also we are a completely different company. The answer would hold for us as well. What we're seeing up to now is that every factory has its own set of factory operational system. It has the same name, but every system is tweaked for every single one of the 120 VW Group plants. Right now we cannot scale one solution from one factory to another. So the first thing we're doing right now, and you may have read the news about that, we teamed up with AWS and with Siemens to form this digital production platform. So to build a new factory operation systems that lets us control and run our factories. And then again, from there are IP instances where we know how we automate things, how we drive the processes that we'll want. First of all, usually in our business, they are time critical, so you cannot run them in the cloud just for latency issues. That's the one thing. And the next thing is, for IP issues, we'll want to run them on-prem in our factories and to keep the IP. So we'll do both. We'll go into the cloud where it helps us. We'll move it closer to the factory where latency requires us, or where other reasons will make us wanting to keep the stuff on-prem.
John, could I ask you perhaps, are you seeing from customer point of view, what are they moving to the cloud? Do you have any comment?
It's very similar to what you're describing. The customers I visit want to keep a set of data on the shop floor. They want to do computing at the edge, figure out with our hybrid cloud solutions, like how do they do some of that technology down at the edge and then take what's needed up to the cloud to do other iterations of artificial intelligence or combining it with other data sets for visibility. But it's very similar. So,
I believe we have a question over there.
It's me, Sid. What I was going to ask everyone, because I'm an ARC person, but we see digital transformation as a very big thing, and I've seen tons of really clever uses of new technology and connectivity. I just love that. But I'm wondering, how do you actually get it? Are you doing anything to push the adoption within the factory? One thing is to go and move data, collect data, and bring it back to engineers who already have this thirst for data and want to analyze. But the things like, the augmented reality, the glasses, all those kind of tools which are supposed to help the workers. Now, they aren't the ones asking for it. I think it was a wonderful presentation this morning where you see IT and the operations getting together. Wonderful. It's got the support to push it out. But in the end, to be successful, you have to get the people there to actually leverage it or to get that value. And I just was wondering, do you have programs? Are you anticipating that? Like the Dow, I know you have the center, which I thought was wonderful, to prove them, to test them, to decide what works. All that's wonderful. But in the end, for the ones that are used like by people on the floor, how do you get them to really use that and want to use it?
Billy, go ahead.
Well, first and foremost, if you're going to deploy to the manufacturing floor, to the shop floor, it better work. And it better work 100% of the time. Because as soon as you have the first failure, your credibility as a new technology deploying organization is blown, and you're going to lose word of mouth across from one site or one plant to another. So resiliency and robustness of that technology that you deploy is first and foremost a criteria for having it be accepted. Melanie and Peter talked a lot about a digital operations center. The other arm of our approach to empowering or bringing in the rest of the organization is we have at every major site basically an innovation network which we use to groom and cultivate organically derived value opportunities or problem statements or pain points or whatever you like to call it from the workers. And we weave that into our project portfolio to make sure we're engaging them and that they see there's action on their ideas. And if it's something they propose and it's something that's solving a pain problem for them, then they more readily accept it if it works and it's reliable. And so we take a twofold approach to that. One is kind of this technology scouting and developing within the DOC. The other is the organic growth, and then making sure that whatever we deploy to the manufacturing environment is hardened.
Henning?
For me, in another part of an answer to that question is trying to phrase this in English, how to overcome the culture of not invented here. And what we figured out for ourselves is that it was really, really important to very early on involve the customers, the ones who are actually going to use the technology in the development process, and make them as early as possible the project leads of that project. Because in a lab, you cannot develop anything to 100% fail-safe. So you'll always need the real operations to pick up and then bring whatever you're bringing into the factory to bring it to the level where it's actually useful for production. And they have two choices. You have something that already achieves 80% of the specs you want to have, and then they can either say, hey, listen, those 20% don't work. As long as they don't work, you don't come into my factory and deploy it. Or they say, hey, this is my baby. You did a great job in the lab, and now I take over, and I and my people, we are really going to push this and are going to leverage what's within this technology. So it's this cultural thing, and so that's what I told our board member of the production. I told him, hey, listen, as a production lab, we are not successful when we come and report on a monthly basis to you how cool we are and what new technologies we have there, but we are useful for Audi if the factory, the heads of the plants come to him, to the board member, and say, hey, listen, we had this real cool idea, and we were really quick, and we deployed it now, and yeah, those guys from the production lab, they helped us. So not to take ourselves too seriously, but actually involve the people who are going to use it into your development process. I think that is key.
Don, would you like?
Yeah, Sid, I'll just pick up a couple of examples on your question about industry uptake. So you asked about wireless, for example. Wireless uptake is fantastic. Demand is exceeding supply in my perspective. And so, like, wireless sensing and wireless for field worker mobility solutions is really, the uptake is very, very strong. And I think one of the challenge questions in there is what we're currently deploying is based on, IEEE 802.15, IEEE 802.11 technologies. And I really wonder, is 5G going to be the winner in the long term? When I go to Europe and talk with the Namur folk, I mean, they're all about 5G. When I go into the tech industry venues and talk, like when I go out to Santa Clara and visit with the Intel folk, it's all about 5G. So I really wonder, there's a technology change here on that one, but the demand and industry uptake is unequivocal, definitive on wireless. You asked about augmented reality. I mean, for us, augmented reality for these types of solutions are still science projects. The devices that we have seen are not really fit for purpose. I mean, if you've ever put any of those helmets on, they're just too damn heavy. I mean, nobody's going to wear it for more than an hour. So we still need some, improvements in the underlying technology in that case. So there's just two answers, specific answers to your question.
Good. I believe we have a question there. Yeah.
Yeah, my name is Michelle. I'm from Fortinet, a security company, a global security company. And the question that I really have is that there doesn't seem to be a conversation about how to secure this innovative change within the industry. So at this particular point in time, when you divide IT and OT, I heard on the panel that you believe in 100% availability, but the reality of it is that IT has never shown 100% availability within their solutions, and that we have an epidemic of ransomware at this particular point in time that is impacting operational environments. And so we had a question about 2030. If we reach out between now and 2030, how do we keep this innovation going, and how do you balance risk with innovation within your organizations?
Anyone like to start? How do you manage risk?
I'll give it a try. I think in the past, what we did in automation, programming PLCs, networking the PLCs, and all these kinds of stuff, we were thinking that cybersecurity is okay if we just build up a big enough firewall around our factory sites, period. That's it. And it's slowly tickling down into the knowledge, into the brains of the people that is just not enough. So what we need to do in the future, and what I think we'll definitely have made a couple of really big steps by 2030 is to deploy technologies that will actually let us monitor the risks. Right now, we probably wouldn't even notice if anybody hacked into a PLC and would have changed something in the PLC as long as the PLC is still sending out the same signals we expect it to send. Hey, everything's fine. So the question is, how do you detect an intrusion? And once you detect it, you can think about, okay, how do I work with that? And there are technologies like that based on data center technology. So why don't we start thinking of our production sites like them being a data center? For our Ingolstadt plant, because I have that number in my head, in our Ingolstadt plant, 2.6 square kilometers, 45,000 IPCs driving our operations within the plant. Do we manage them like a data center? Well, no. Why? Well, the answer to that is because every single one of them, at least a large portion of that, is set up for one specific task. If you just roll up a security update, are you sure the drivers will still be working once you made that security update? And the answer is, well, I better check. So once you have something, you walk to every single one of those IPCs to do a manual update. Is that the way you want to do this in the future? No. So these are fundamental things that I think will have changed by 2030, and we have some ideas on how to push that.
Excellent.
So, it's funny. In preparing to answer a cybersecurity question, this is what I thought I would really say. At this conference, maybe half a dozen years or so ago, and similar conferences at that era, at that day, at that time, a lot of the discussion was, hey, you technical guys, you need to raise the awareness of your management ranks about cybersecurity risks. That's not really the way the story played out in ExxonMobil. Okay, I mean, our CEO at the time, Mr. Tillerson, basically called engineering into his office and say, hey, engineering, what are you guys doing about cybersecurity? Okay, we have cybersecurity as a corporate level risk. It has visibility at the absolute highest levels. So where are we today? I think we've got a whole plethora of defensive technical solutions in place. We've raised the awareness of all employees. We've almost got cybersecurity to the same degree of awareness at the individual employee level as we have with process safety. Okay, we've got work practices to assure proper cyber hygiene, for example. Okay, we've eliminated all uncontrolled USB ports, for example. We hunt and destroy unauthorized network connections from our systems. And not to talk about futures too much, but again, bringing in technologies that have been reduced to practice in the IT domain. We're talking about hardware root of trust. Whitelisting is very mature in our world. So, I mean, I think we're getting there. I think we're getting there. And yes, it's very dangerous. And yes, the threat is adapting, and we've got to constantly evolve. I think we have to mature to enforcement. I mean, work with governmental agencies to go after bad guys. There's a policing aspect to this as well. But it's not as bad, I would submit, as your question implies.
Yeah.
May I ask from supplier perspective, John, but perhaps, how are you embedding cybersecurity into your products?
I mean, as Don mentioned, it's at the C level, right? It's at the boardroom level where they're concerned about cyber risk. And right now, across the globe, there's a $6 trillion problem and about roughly the estimates are $1 trillion spend toward that problem. So it needs to catch up. There needs to be a greater investment in making sure that your systems are protected, well protected. As far as in the world of Microsoft, as I said in my discussion a little bit earlier, we have applied $1 billion a year resources just in our cyber area. So going forward, you'll be assured that we're doing the best we can to help you as customers in locking down your systems.
I just wanted to touch.
My answer will sound. Oh, I'm sorry, Bill.
Go ahead, please.
My answer will sound similar to Don's. I mean, we have instantiated the training and the awareness throughout our entire organization relative to security and how we develop products. We have processes that provide oversight to ensure we're doing our best to ensure the security of products, et cetera. And those kinds of capabilities are what need to be ubiquitous. And we also, with the ongoing the reality of our world, of the ongoing threats, et cetera, making sure that we're always updating and providing the latest with the capabilities to address any of the threats as they arise. So it just needs to be foundational, and it has the C-suite visibility in our organization as well.
Yeah, I think I want to just tease out one point that Don made in his comment about the people. Any system you put in place can be defeated by a person inside your company, probably, or outside your company. This concept of tying together cybersecurity, physical safety, or classic physical security, as well as process safety and personal safety is an approach that we've really trying to push with inside of Dow. Is if we get to the level of awareness, and your comment about elevating the approach, get to the level of awareness we have from a personal safety and process safety standpoint that we do with cybersecurity, then we've accomplished a lot, especially for the process industries. And those two, at least in our industry, are inherently connected. If you have an intrusion in a refinery or in a materials plant or ethylene plant, that has real potential physical impact in addition to a cybersecurity impact or loss of IP. And so we continue to push on that platform. Peter and Melanie didn't show it in the schematic, but our Manufacturing 4.0, one of the key platforms or tenets in that is physical and cyber safety. And so we start to tie those together very closely, and that's the approach we use to try to drive the culture, that cybersecurity is in fact every employee's responsibility, just as it is for physical and process safety.
Can I add one more thing? We actually just completed a study of over 400 from executives to the operators on the manufacturing floor to understand what was top of mind in the digital transformation space. Of course, how do you deal with data and having data science? How do you have more modern software development techniques, et cetera? But cybersecurity was in the top 5. I think it was number 3 in that study. So echoing the point made here, I think the industry is, now the awareness is there, and it's making sure we have the right training of the individuals, of what their role is in it, and making sure the infrastructure is safe.
Oh, do we have a question over there?
Over here.
Okay, yeah, go ahead.
Sort of a two-pronged question. When we talk about the adoption of the new tech out into the plants, do you sell it down to them, or do you give it away to them? In other words, do the business units still have to pay for the new tech as they bring it into their plants? And then also, could you speak to how you guys are developing the support structure for the new tech that arrives in the plants? Are you building out your automation system techs? Are you building the new skills into them? Are you creating a whole new OT layer? A little bit, if you could speak a little bit into that.
I'll try. I hope I can capture all the questions in there. First of all, what we do in the production lab is for free for doing this proof of concept. So we together with the one who wants to have it, we go and try to get the money in order to do the POC. But the POC doesn't help you. What you need is you need to scale it out. And as soon as you want to scale it out, it becomes a real project like we would do it. There is an ROI, and based on this ROI, there is a time frame by when it brings back the money you invest into that project. So that now then goes into the official channels, the way that our company works. So as I said, we have some money to do these POCs. And to tap into, will this actually work? And once we're sure it works and we can calculate the ROI, then it goes into the official business case channels to scale this out. And you have to do it that way in order to get the entire company behind the project. That's one part of the answer. The second is, we have a very good, as I said, we try to involve the people who are actually going to use it very early into the POCs. And by involving them into the development, we make them experts in whatever is going to come their way further down the lane. So we train them by working with us on the project, get the right people in there, and then they move with their project back into their production line and are then the experts there and train again their colleagues on how to use this new technology. So it's kind of like a vocational thing of getting this knowledge of the new technologies into the brains of the people who have to work with it. And that's what we figured out what works really well to get the people with the right mindset or have them develop the right mindset in order to bring the technologies into production, in the production line. And once it's installed in one plant, to scale it to the other plant, that's easy again. You have people come over, learn, train on the technology in one plant, and then take that technology with them to the next plant.
Yeah, I think for us, the short answer is to your question on investment. Once it's being deployed globally, similar to Audi, it's a project. It has to show return. The business has to pay for that investment, and they have to include that. From a competitive analysis, do they have other things that are better investments than what we're trying to deploy? And that's the only way you can keep the financial returns square across other opportunities where you might deploy that cash.
Yeah, in our case, once a technology has been proven with the initial pilot or champion site demonstration, which is usually financed by R&D dollars, that's again, same thing you heard from Billy and Henning. But basically, there's two paths to deployment in our world. You can either, and this is the Occasionally, we use a mechanism of what we call a venture, which is the business funds something for deployment through all of manufacturing. Every once in a while, that happens. Most of the time, individual ideas have to compete on the basis of ROI for investment at that site. But the one thing I want to highlight is in ExxonMobil, and I'm really talking about the refining or the downstream company and the chemical company. Most of our instrumentation, analyzer, control systems, and control applications talent are employees of the operating companies, not of research and engineering. And it's a general principle for us in the research and engineering company to make our site-based staff as capable as possible, because we want them to sustain these technologies, not central engineering. It's a basic principle of how we operate, and that we consider that one of our keys to success.
Excellent. We have a question over there. Go ahead, sir.
Hi, this is Adi Dora from Reliasoft. I wanted to get your thoughts more on something we've heard mentioned today, and it's part of the track, which is equipment performance, reliability, and things like predictive maintenance. What kind of applications or solutions that are going to be really important for you that you're looking for or either developing, and how do you see the role of vendors in that to help you either accelerate in that effort?
Maintenance.
Well, I think the question was about predictive reliability. Yeah. And so it's been a long journey for us. We frankly don't have much to show for it. We haven't given up. It's one of our biggest areas. When we look at value propositions, it's still one of our biggest opportunity areas. Still very much an active research project, and we are working both internally with technology developments as well as working with vendors. That's our short answer.
I could just say ditto.
Henning?
Now I need to say something else, but ditto. Yes, predictive whatever is the goal we're striving for. Now, what I try to explain with the POC of the analytics of the spot welding, what we need or what we want to have in the future is to have an open platform where we can then just buy services, buy predictive services by the companies who know their equipment much better than we do, and deploy them on an open platform. Why? Because we do not want to get locked in with one specific hardware or software piece. We want to have an open software, and then we can say, hey, listen, for your spot weld controller, you have a new service, and if there is an ROI for that service, we'll want to deploy it. If there's no ROI, then we won't. And so this predictive is always competing with what we've been doing so far. So far, we have not been doing predictive maintenance, but preventive maintenance, for one. Plus, we have been doing predictive maintenance in the brains of our maintenance people who walk along the line and say, hey, listen, this is sounding different from yesterday. Oh, I know that. Next weekend, I'll check there because this screw came loose or whatever bearing is not working right anymore. And get this information and get this knowledge out of the brains of our operations people, and then transfer that into predictive whatever. That is a challenge, and that's a long journey. But I think that's the way we're going. But we need to do a lot of homework first before we can do things like that.
I believe we have a question over there, sir.
Hi, this is Brian Atkinson from Horizon Controls Group. And I was curious, as you're going through and modernizing your control systems and assets, first, how do you avoid falling into the trap of just doing a like-for-like replacement where you can take advantage of new technologies? But beyond that, how are you setting yourself up to be prepared for what's coming 5 years from now so that your systems are ready to adopt new technologies as they get out of proof of concept or just become available?
Yeah. So Billy's jabbing me to talk about OPA. So, Listen, I mean, you really don't want to be in a like-for-like scenario, but sometimes if there isn't a better solution, then like-for-like is the way to go. Sometimes for financial reasons, you're forced into like-for-like because maybe that is the lowest cost way to stay in business for a little bit longer. But if you do have the opportunity to make an investment in strategic improvement and it's a little bit expensive, then the like-for-like, I mean, you could go back and read the reliability engineering books. They tell you how to do these calculations. So the OPA value proposition is this is the strategic improvement that we're offering. So we would like to be able to make that investment, and that's so that's the kind of the short answer to the control systems challenge that we're facing. I invite the others to comment.
You got to think about in this space. We have control systems operating today that are nearly 50 years old, right? And the mindset was you put in that control system and it's probably going to outlive the useful life of the plant, or at least come close to being equivalent. And what we see is that our hardware and our physical plant itself is outliving beyond the useful life of the process control system. Dow, in our history, we went down this path of developing our own internal process control. We have, if you Google Dow mod, you'll find a lot of nice web pages about the Dow mod process control. It was built 40 years ago, and other than the lack of components and the hardware failure, the robustness and resiliency of that system today and the way it's designed is just about as capable as anything you can find on the market. It just, technology has advanced in terms of communications, what we want to do with that data, how much data we want to move back and forth out of process control layer. When you talk about preparing for the future, much like Don, if we have an opportunity to upgrade and add capability when we do a retrofit of a process control system or an uplift, we certainly want to do that. We want to be able to add plant capacity or yield improvement or raw material improvement or emissions monitoring or emissions reduction capabilities if we can. It may not always be the case. Remember, we've optimized our plants for 40 years, right? So we've done a lot of good work in optimization already. So we have to balance the cost of an upgrade versus a like-for-like and what the return on that is, and then also look at the expected robustness and resiliency of the process control system which we're implementing as a replacement. Those are key qualifiers when we look at our process control upgrades and retrofits.
So the reason Intel leaned in on the Open Process Automation Forum was we saw the possibility of how do you ultimately get to an open platform that you can evolve over time? How do you virtualize workloads? How do you make them more software such that you can orchestrate them across and have that flexibility over time? And if you'd like to see more, we do have a demonstration in the booth area talking about where it is. And that's why we leaned in on the technical committee to help with some of those interoperability specs. We believe there's the possibility of bringing that to, I'll call it more future-proof, such that you have the capability to do those updates over time and have the interoperability specs for switching out the equipment as it evolves over time.
I will add to Don, I think, was very humble. He did not mention, in fact, ExxonMobil, the reason they started Open Process Automation Initiative was because they did not want to replace like for like. They wanted to actually, obviously, going forward, incorporate some of the enhancements in the technology. And I would actually, again, add, just like actually it's happening in our phones right now, whenever there is a new version of the operating system or whatever applications, actually, obviously, we download it. And I would say what Christine is alluding to, I would encourage you folks to learn more about it, what's really happening. We are bringing the same kind of actually virtualization down to the control systems and field devices and so forth, so that we can more easily upgrade the software so that we can incorporate some of the newer functionality. So I think there's a lot of progress being made towards that, and we have to, in fact, move in that direction. And there is a lot of innovations taking place in that arena. Let me see, do we have Another question in the audience? Okay, go ahead, sir.
Yeah, my name is Miguel Fernandez from Siemens. We have heard now several times about the difficulties to evaluate the added value of modifications and innovations in the process industry or on the plants itself. So I think the digital twin in this respect gets a lot of more importance. So because the vision should be that the systems itself tells us what this modification means. So, but we need these digital twins in our architectures. And I would like to know what you think about this, that the systems, the processes itself are represented by this digital twin, are able to simulate the reaction, and then, we can evaluate this impact. And what do you think about this implementations of this digital twin?
Anyone like to take a stab? Go ahead.
Yes, Miguel, the digital twin is a term that is subject to subjective interpretation. So whenever I hear a question about digital twin, I want to make sure we're talking about the same thing. So, let me assert something first, and then I'll drill down into my response. I would assert that at least in terms of dynamics and controls, we've had digital twins of our plants for decades. I mean, most of our big refining and petrochemical assets are controlled by a suite of mathematical model-based applications, both for dynamics and steady-state optimization, that represent a pretty significant digital twin of the plant process behavior in total. Now, when I go and talk to equipment type of folk, most people think of digital twin as more or less a static representation of that piece of equipment with electronic storage of the type of data that you'd want to get from a digital twin. But rarely do I see anybody having any equivalent to what we have of modeling the behavior of the process, anything representing any type of a simulation model, be it static behavior or dynamic behavior of that piece of equipment. So you got to be careful when using that digital twin term. What are you really, really talking about? The concept is clearly valuable, okay? Clearly valuable. But what are you really investing in when you talk about digital twin? I'll stop there. I don't want to go on a big editorial.
I think Don is correct in that assessment. From a process industry perspective, so when you talk about materials or refining or even nuclear, we have a lot of good data. We're able to simulate our process in entirety very well, and we understand the dynamics of how that behavior is going to work. I think one of the things that we've seen in the analytics space and the data crunching vendors that come talk to us is, at least for us, without domain knowledge, they don't understand that our processes are already constrained. If you want to go build a model, we have laws of thermodynamics, we have physics, we have the chemical engineering principles, mass and energy balance, and once they were built. And so those have to be considered when you go to build a simulation or a digital twin. You just can't walk in off the street without some of that background and knowledge and come and solve any problem we have. I think the other place where I see model-based improvements is in the capital execution space for our facility. So having a real dynamic and updated model of the physical plant itself and what changes have been promulgated over the last 10 years when you want to go in and do a retrofit, having that live and being able to have engineers deployed across the world, not necessarily in that facility, see a real visualization of what that facility looks like, be able to walk through it, be able to go in and make a change and have that change visualized by a team in another location. I think from a capital project and maintenance and improvement project perspective, there's a lot to be gained by using a physical digital twin, including things like a point cloud and visual image, as well as the modeling and simulation that Don talked about laid on top of that. You can get some real advantages there.
Henning, would you like to say
Yeah, I don't have much more to add. I mean, we've been using digital twin simulation tools for planning our plans, for setting them up for seems like decades now. It's always a question of once the factory is running, how do you keep those digital twins updated? Because up to now we only use it for planning and setting up a factory. And after that, for the operations, the digital twin is not useful anymore, so it doesn't keep or is not updated anymore. So there's the cultural change that needs to take place, because if we want to include something new, it's always helpful to start not from the digital twin where you had 4 years ago when you set up the plant, but from the actual state of the factory 4 years later, because due to all the improvements that factory changed. So yes, that is useful. And the bigger thing is we need to understand our processes along the entire process chain. And so that's the knowledge. This process knowledge is something, as you said, it's a domain knowledge that's not found outside of our factories. And even within our factories, it's hard to find people who have enough domain knowledge across several fields so that you need to interconnect them to get an entire view of what your factory is doing. We tend to think building a car is something very physical, deterministic, but it turns out if you really drill down into it, into the errors that come up a couple years after you set up the factory, the systematic errors we eliminate in the ramp up. But those errors that come up later are errors where very unlikely events in the, steel coil production have an influence on your body and white shop, which will have an influence on the paint shop, which will have an influence on the assembly lines. So these processes, to understand those, that's where we have to build up the domain knowledge first and figure out how to do that in order to actively influence our production process to cope with those varying incoming supplies, materials, and processes.
Yeah, it depends on your definition. There's a presentation on Thursday by Dana Corporation through inductive automation, and you'll see their version of a digital twin in their factories and what they've done to date. So essentially a 3D model of the entire interior of the factory using point cloud data, then taking all the data from each machine, putting it into that model, so now you have visibility to all the metrics inside of each piece of equipment, gathering that all up, calculating OEE. They're transforming all their plants globally with this initiative. It's pretty amazing.
Yeah, this is an area actually there's a lot happening. More and more companies are starting to obviously, have more equipment, static models, but you need to start adding operating data to the equipment. Then it becomes far more useful. And I think some companies out there are starting to do that. I think we are coming close to the end of our time. What I'd like to, in fact, ask maybe each one of you perhaps any last thought you have, the last message for the audience, any last comment you would like to make? Maybe, John, I could start from this end, from you.
Yeah, as everyone said on stage, a lot of the transformation you're undertaking is technology driven, but it's also culture. So the marriage of those two, the IT and OT, as Dow spoke to earlier, is very important. And the cultural transformation has to be there. Just wish you all the success in your journey, and hopefully, everyone here on stage can help you answer any questions you've got.
The parting thought I'd give is start somewhere. We actually will often engage with different manufacturers and get stuck in okay, how do I return on investment? How do I get started? And we found you see the return happen, whether it's a particular solution for an inspection on a quality step or adding some sensors to detect a failure of a piece of equipment. Start somewhere. Then you have to think about the bigger picture of how you're going to deploy it. And I think the panel shared many of their ideas of more the bigger aspect of how you have to consider how you're managing that data, how you're managing that infrastructure, and bringing those solutions. But start the journey is my point.
So I think the stars are aligned, and the time is now to achieve a step change transformation in our OT technologies. And just to build on something that Christine said earlier, there was a question in one of the workshops yesterday about when will OPA conformant products be available. So let me just mention, there's 4 suppliers over there in the exhibit area that have been contributors of component products to ExxonMobil's prototypes and proofs of concept, and you can go and talk to the suppliers about this. Intel, ABB, Phoenix Contact, inductive automation. Okay? The stars are aligning.
Yeah, I guess my my parting advice, you can take it or not, it's maybe worth a nickel. Don't worry so much about the tools. Don't become enamored with the tools and with all the fun devices and everything that you can do in this space. The models are great, the mobile devices are great. First and foremost, think about what it is you're trying to do and what you're trying to accomplish. Right? For us, it's about improving our customer expectations and our customer interactions. It's about making our workforce more engaged. Productivity, safety, reliability, sustainability, and profitability. Whether it's a process technology improvement or a new product or some other manufacturing tech or digital technology, we strive for those handful of things. And basically, I'm technology agnostic. As long as it gets me to that objective, it doesn't matter to me if it's an IT, OT, or if it's a new catalyst, or if it's a new polymer, or a new adhesive, or new silicone. And so what I would say is think about what it is you're trying to do and then look for the technology that will help solve that and bring the ROI and the value and the cash generation you need in order to make that investment.
No, I have the hard part of being the last one. I think probably all of it was said already. For us, the key is to go from a business value to look into technology, where can it help us, and do it both ways. Go the push and the pull. So push new technologies, try them out, and figure out, okay, do these new technologies enable us to do things differently from what we've did in the past in order to do a jump in the evolution and to become better? But don't forget about the pull. Where's the business value? What do you want to improve? And then with that business and with your production in mind, go out and search for the technology that will help you there at this point. And don't only look at the short side, but look at, okay, what is really causing the problem? Because if you talk to somebody in the process, they say, okay, what really hinders me here is that this screw doesn't fit into that hole. The question is, well, why don't they align? What do I need to do in order for those pieces to align much better so that the one actually doing the work doesn't have this problem anymore? So think out of the box.
A couple of housekeeping things, folks. We are now breaking for lunch, and we will have lunch also placed in the foyer as well as outside. And we also have 2 workshops starting in 15 minutes in the rooms in the back. So please go and enjoy the lunch, and we will start our next sessions at 2 o'clock. With that, please join me thanking our panel here. We had a great discussion.